Hey everyone, so here's the page-by-page video solutions to your integrals test 1 review. Okay, so for number 1, we've got for some function f prime of t is equals 3t squared minus 4. If the function has a value of f of 0 equals negative 2, find the value of the function at t equals 3. So look, we've got to figure out what we have here. So what we have here is they gave us a derivative, they gave us an initial condition, and we're looking for something else. Okay, so this is screaming net change. So remember, net change said, let's write that up here, net change said that if we have the integral from a to b of f prime of x, that is going to equal f of b minus f of a. So how are we going to set this up? Well, this is your a, the 0, and this is your b. That's what you're going to, right? So you're going integral from 0 to 3 of f prime of x. Well, this is your f prime. That's the equation they gave you, 3t squared minus 4. And that equals f of b, so it's f of the top, minus f of a, which is f of the bottom, which is f of 0. Okay, now let's go ahead and find out what this is. So what is the integral of 3t squared minus 4? Since I have such sad little room here, let me do it on the side here. So the integral of 3t squared minus 4 from 0 to 3 is going to be, that's 3t cubed over 3, or just t cubed, minus 4t evaluated from 0 to 3. Now look, if I plug in the 0, both of these are going to 0 out, so I can just cross that off and just plug in the 3. So this is going to be 3 cubed minus 4 times 3. 3 cubed is 27. 27 minus 12 equals 15. So this whole integral here then is 15. Now, what is f of 3? Well, that's what I don't know. That's what they were asking, right? What is the function when f equals 3? So I'm going to keep that as an f of 3. But I do know f of 0. They gave me that right here. That is negative 2. So what I have now is that 15 equals f of 3. A negative and a negative make a positive. And then if I subtract 2 from both sides, I'm going to get that f of 3 equals 13. All right, so that would give me an answer of A. So you guys look for that. Again, what are the 3 key things for net change? Derivative, initial condition, and you're looking for something else. Okay, now number 2 we actually did in class today, okay? So you guys, this right here, and kind of like go through your head, like what theorem is this? What am I using? Okay, then whenever you're taking the derivative and integral, this is FTC2. So FTC part 2. So the derivative and an integral cancel out, and then the square root of x is going to hop in for that t. So you're going to end up getting 1 over 1 plus the square root of x squared. Remember, the t is getting squared, so I have to square it. But then you guys always chain rule it, no matter what. Okay, so the derivative of the square root of x, that's what I'm going to be doing right here. Derivative of the square root of x is 1 over 2 rad x. And then let's just simplify this a little bit. I know that, oops, I forgot to square this. Sorry about that. No, I didn't. Okay, so a square and a square root cancel out. So this is going to be 1 over 1 plus x times 1 over 2 rad x. And if you notice, like 1 times 1 is 1. The answer is A, by the way. So 1 times 1 is 1. And then 2 rad x times 1 plus x is this, 2 rad x times 1 plus x. Okay? All right, know that one. It's an easy question. Let me box the answer there. Okay, let's look at number 3. So number 3, we've got time equals 1. There are 500 gallons of oil in a huge tank. So that means that f of 1 equals 500. So I've got myself an initial condition. Oil is leaking out of the tank at a rate of, okay, you guys remember rate just means derivative. So this right here is your f prime of t, which is 1 minus 30 rad t. So look, I've got an initial condition, I've got a derivative, and I'm looking for something else. I want to know how much oil is in the tank at time equals 4. So this is your f of 4. Okay, so again, set up net change. So this is going to be, doing a different color here, the integral from a to b. Now, what is a, what is b? Here's your a. And here is your b. So it's the integral from 1 to 4. Always keep the smaller number on the bottom, okay, Of f prime, what's your f prime? That's this guy right here, 1 minus 30 rad t. And that equals f of the top minus f of the bottom. Okay, now again, I need to figure out what this is right here. So let's do it on the side. Maybe we could do it like right here. So the integral of 1 to 4 of 1 minus 30 rad t is really t to the 1/2. Let's go ahead and change it to that. So what's that going to equal? The integral of 1 is t minus, and this is 30. If I add 1 to this, it's going to be t to the 3/2 times 2/3. And I'm evaluating that from 1 to 4. But let's fix this up a little bit because it's kind of gross. What's 30 times 2/3? Well, that's 60 over 3, which is really 20, right? So I can rewrite this as, still running out of room. This is t minus 20, t to the, and t to the 3/2, that really means the square root of t cubed. And I'm evaluating from 1 to 4, okay? So if I do top minus bottom here, set up the little template, top minus bottom. If I plug in the 4, this is going to be 4 minus, and then, oh my gosh, do I have an extra t in there that I don't need? Yep, I put 2 t's in there. You guys, do you see this little guy? Shouldn't be there. I'm like, how did I get an extra t? Let's erase that. So sorry. Okay, let's do it now. Okay, so if I plug this in, if I plug the 4 into here, okay, you guys, 4 cubed is 64. The square root of 64 is 8, and then 8 times 20, well, that equals 160. And then if I plug in the 1, the bottom here, I'm going to have 1 minus 20 times, and if I plug in the 1, 1 cubed is 1, the square root of 1 is 1, so it's going to be 20 times 1, which is 20. So what do I get here? This is going to be 4 minus 160 is negative 156. Get the 1. And then this is minus 1 minus 20 is negative 19, so it's really plus 19. Okay, and then if you do 156 minus 19, let's see, it's going to be 7. 4 minus 1 is 3. So it's going to be negative 137. Okay, so this whole integral is negative 137. So let's put that in there. Negative 137 equals, I forgot the f of b minus f of a. Oh, I'm putting it in the wrong place. Negative 137 equals, sorry about that. My gosh, I'm messing this up so bad. And then f of 4, I don't know. And then minus f of 1, if I plug in, what was f of 1? F of 1 was 500. Okay, and then adding 500 to both sides. So f of 4 is going to equal 500, if I add it to the other side, minus 137. Okay, so 500 minus 137, what would that be? Let's see, that's 500, that's 400, 370, 363, I think is the answer. Okay. All right, now let's look at number 4. Okay, here we want to calculate a left Riemann sum from 0 to 6. So if you're doing a left Riemann sum, let's look at the intervals. So my intervals are first going to be from 0 to 2, then from 2 to 4, and then lastly from 4 to 6. Okay, because I'm doing a left Riemann sum, I want to highlight all the left values. And then you guys, Riemann sums are just literally base times height. So what are we going to get here? The base is the distance from 0 to 2, which is 2. And the height is not this highlighted number. It's the value at that highlighted number. So at x equals 0, f of x equals 5. Then plus, again, base is the distance from 2 to 4, which is 2. And the height is not 2. It's not the highlighted number. It's the value at that number, which is 8. And then plus the distance from 4 to 6 is 2. And the height, again, is not this 4. It's the value at 4, which is 2. So this is going to be 10 plus 16 plus 4, which equals 30. Okay? Now let's do the same thing with a right Riemann sum. So the intervals are the same. Except this time, because we're doing a right Riemann sum, we're going to be highlighting the numbers on the right. Okay, so again, we're just doing base times height. So the base here is still 2. The height is the value at 2. So the value at 2 is 8. Then plus the base is still 2. The height at 4 is 2. And then the base here is 2. And the height at 6 is -1. And because we have a negative height, it just means it's below the x-axis. So this is 16 plus 4 minus 2, which is 18. Okay, a trapezoidal sum with 3 trapezoids. So again, the intervals are the same. So you're going from 0 to 2, 2 to 4, and then 4 to 6. Now you guys remember for a trapezoid, because I have 2 heights, I'm going to be highlighting both of these guys. And the formula for the area of a trapezoid is 1/2 base times height 1 plus height 2. So it's going to be kind of gross plugging all this in, but we could do it. So look, I have 1/2 times, the base here is 2. Now height 1. So at 0, looking at our little table here, at 0 it was 5. And then at 2, it was 8. Then plus 1/2 the base. The base here is 2. At 2, it was 8. And then at 4, it was 2. Okay, and then the last one, I have 1/2, the base is 2. At 4, the height is 2. And then at 6, the height is -1. Okay, now the nice thing about this is that half of 2 is 1, half of 2 is 1, half of 2 is 1, so I can get rid of all those. So really, I just have 13 plus 8 plus 2 is 10, and then 2 minus 1 is 1. So this is going to end up being 24. Okay? All right, now number 5, this is something that we learned in class today, average value. Okay, make sure that you learn this. Average value is 1 over b minus a, the integral from a to b of f of x dx. Okay, now the question on this one though is it doesn't really give you what the a and b values are. It's saying that your a and b values are the x-intercepts. You guys, the x-intercepts is where the graph crosses the x-axis. So it's basically where y equals 0. So I need to find those. This one's a little bit tricky. So if I set 0 equal to y, I'm going to get 0 equals x minus x squared. How do I solve that? If I factor out an x, I'm left with 1 minus x. So setting both of these equal to 0, I'm going to get x equals 0 and x equals 1. So this is now going to turn into my a. This is going to turn into my b. So plugging this in, I'm going to get 1 over your b is 1, your a is 0, your a is 0, your b is 1, of your function x minus x squared. Now this is kind of silly. You guys, this ends up being 1 over 1, which is just 1. 1 times anything, just multiplying it by it does nothing, so I'm just going to cross it out. Okay, the integral of x is x squared over 2. The integral of x squared is x cubed over 3. And I'm evaluating from 0 to 1. Again, if I plug this 0 into both of these x values, it's just going to 0 out. So I don't even need that. So all I really need to do is plug in that 1. So this is going to be 1/2 minus 1/3. The common denominator is a 6. So if I multiply these by 3, multiply this by 2 to make both of those a 6, I'm going to get a 3 minus 2 there. 3 minus 2 is 1 over 6, which gives me D. All right, so there's page 1. And I'm going to stop the video and make page 2.